everyone, myself Srijita Shaha, and today I will present my analysis on Netflix stock price stationarity using the Augmented Dickey-Fuller test. This is the statistical examination that describes whether Netflix stock data is suitable for reliable financial modeling and forecasting. Here, I will explore how the ADF test methodology transforms raw price data into stationary returns, enabling accurate portfolio management decisions and risk assessment procedures for investment professionals. Here, I have shown the agenda of our presentation that includes understanding the time series stationarity fundamentals, exploring the methodology of ADF test, analyzing Netflix stock characteristics, implementing step-by-step procedure, and interpreting the statistical result with the evidences. So, what is introduction to time series stationarity? Let us see that. Time series stationarity requires constant mean, variance and autocorrelation structure across different time periods. Non-stationary data creates spurious regression results and unreliable investment forecasts, potentially costing investors significantly. Most stock prices exhibit non stationary behavior due to the trending patterns and the structural market breaks. Stationarity testing is helpful as analysts can select appropriate modeling techniques for portfolio management decisions and ensuring the statistical properties remain constant over time for reliable financial modeling and accurate forecasting results. In this slide, we will see what is ADF test. The ADF test determines whether time series contains unit roots, indicating non-stationarity through specialized statistical hypothesis testing procedures. This process extends the original Dickey-Fuller test by accounting for serial correlation in error terms and making it more robust. This test examines the null hypothesis of unit root presence against the alternative hypothesis of stationarity using specialized critical values due to non-standard distribution conditions and mathematical regression equations with lagged difference terms. For this analysis, I have used two hypotheses. One, the null hypothesis states the series contains a unit root, meaning non-stationary behavior with trending characteristics, and the other alternative hypothesis suggests stationarity with mean reverting properties suitable for reliable modeling. When the ADF statistic becomes more negative than the critical values, we will reject the null hypothesis. P-values below 0.05 will typically indicate stationarity at the 5% of statistical significance level, providing objective criteria for statistical decision making in financial analysis. Our Netflix data captures various market conditions, including the growth phases and streaming industry corrections with high volatility periods corresponding to earnings announcements and competitive pressure from rivals. The stock exhibits growth behavior with pronounced upward trends interspersed with significant corrections. The dataset includes date, open, high, low, close, adjusted close, and volume columns, with the closing price series serving as our primary focus for stationarity analysis and forecasting applications. In order to implement this process, I have used the essential libraries that will include pandas for data manipulation, matplotlib for visualization, and stats models for statistical testing procedures. Data loading requires careful attention to the file format and missing value handling technique. Date parsing will convert string data to datetime objects for proper chronological analysis capabilities. Setting dates as the primary index enables time-based operations and lag calculations necessary for robust ADF test implementation and accurate statistical results. In this picture, I have shown the imported data properly. In this slide, I have shown visualizing the raw time series data that will help me to detect the trends, cycles, patterns, and irregular fluctuations in Netflix stock price. This will provide me a initial evidence of non-stationarity such as upward trending behavior patterns, and volatility clustering behavior. This preliminary step guides whether the transformations like differencing are necessary before formal statistical testing or not. The visualization plot will support me for better interpretation of subsequent ADF test results and strengthens communication effectiveness with stakeholders who may not understand the complex statistical terminologies. In this slide, I have applied the ADF test on the original series, and it shows a negative of minus 1.813 with the p-value of 0.374 that indicates a non-stationarity conclusion for the original Netflix price series. And the critical value comparison shows that there is an insufficient negativity for the statistical significance at conventional levels. These numerical results confirm our visual observations from the time series plot, validating the trending behavior we observed. The non-stationary conclusion suggests that the direct application of standard time series models would be inappropriate and potentially misleading for forecasting purposes. As the data was non-stationary, I have used first differencing, that is a mathematical operation that calculates changes between the consecutive periods, effectively removing the trending behavior patterns from the data. This transformation converts absolute Netflix price levels into daily price changes while preserving important volatility characteristics. This difference series fluctuates around zero with varying volatility periods, showing clear stationarity properties. Visual transformation provides initial evidence that differencing successfully addresses the non-stationarity issues identified in our original price series analysis. After applying differencing the series, this has dramatically improved the ADF statistic of minus 14.242 with the p-value of 1.53 e to the power minus 26 indicates a strong stationarity in the differential Netflix return series. These results provide overwhelming statistical evidence for rejecting the null hypothesis of non-stationarity completely. The statistic becomes more negative than all critical values, indicating highly significant statistics results. This successful transformation validates my theoretical expectation that the financial stock prices become stationary after first differencing transformation procedure. From the results, it can be seen that there is a fundamental statistical differences, and the extremely negative ADF statistics indicates robust stationarity unlikely to be affected by sample variations or market conditions. These results align perfectly with efficient market hypothesis principles and established financial theory. Stationary returns has enabled reliable volatility modeling and comprehensive risk assessment procedure applications for investment decision making. The practical management or applications in financial analysis includes portfolio management that significantly benefits from reliability, volatility measures, and accurate correlation coefficient calculations enabled by stationary data. In the conclusion slide, I have provided the comprehensive analysis that demonstrated that Netflix stock prices require first differencing transformation to achieve statistical stationarity, transforming ADF statistic from minus 1.813, that is non-stationary, to minus 14.242, that is highly stationary. This is a successful transformation that enables reliable application of various sophisticated analytical techniques and forecasting models. This methodology applies broadly to other financial assets beyond individual stock analysis, ensuring proper stationarity testing, maintaining analytical validity across diverse financial market applications and investment strategies. Thank you so much for watching this video. Thank you.